Hello friends, today we are going to learn about double linked list, also known as two-way linked list. Okay, two-way linked list, or you can say doubly linked list. Now, the reason why it is called doubly linked list or two-way linked list is because in singly linked list we have only one pointer pointing to the next node, but when we talk about the doubly linked list, we need to provide two pointers along with the data. I mean, we are providing two data field, two pointer field along with the data field. Okay, so that we can traverse in the linked list in two direction, that is bi-directional. Okay, so in this way our node will be structured for the doubly linked list or bi-directional two-way linked list. So let us see, here we have let's say three nodes. Okay, and initially, since it doesn't points to somewhere, we are supplying null to that. There is a data field here, the mid one, and the next is pointing to the next node, that is 200. So there are two pointers. One is the next pointer and one is the previous pointer pointing to the previous node, while the next pointer points to the next node. Similarly, we have, let's say it is at memory location 100, the head is there pointing up to the memory location 100. Okay, so this is pointing to this particular node. Then we have another node where we have the data as 20, right? And we have a previous pointer where this node points to the previous node, that is 100. Okay, so if you are standing on this node, you can traverse back to this node via this previous pointer, because previous contains the node address of the previous node, while the next pointer contains the address of the next node, that is 300. Okay, similarly for this we have the data like 30, and this previous pointer will contains the address of the previous node, that is 200, and this next pointer, since it points to no node or null node, so here we are supplying null as the address. Okay, so in this way we can have the two-way linked list or doubly linked list, right? If you talk about the structure of the doubly linked list node, that is the node one node, if you talk about the structure, so it will be struct, let's say DLL node. Okay, this can be the representation of this, and inside that we can have in data, of course there's an integer field, and there are two pointers. One is the address of, one is the pointer that contains the address of one previous node, and another pointer we have that contains the address of the next node. Okay, so we have two pointers. Let's say one is pointer previous containing the address of the previous node, and another containing the address of the next node. And what will be the data type of that pointer? It contains the address of structure DLL node. So struct DLL node pointer. Similarly, this is also struct DLL node pointer. Why? Because this pointer is of holding the address of the structure DLL node. Okay, that is why. So this will be the structure of our DLL node in a doubly linked list. Okay, if you we have to create a doubly linked list node, we need to provide this structure as we have provided in the singly linked list. Okay, so this is when we are creating a node in doubly linked list. Okay, so this way we can create, the process will be the same for creating a doubly linked list node. Now, why we have gone for doubly linked list? There is an advantage. You might have right now understood what is the advantage, that we can traverse bi-directionally. Okay, because we have bi-directionally traversal is possible via a DLL doubly linked list. Okay, but it wasn't possible when we had the single linked list because we face the problem that we can traverse only in one direction. So this problem is solved in the doubly linked list. Okay, so this is one of the advantages that we can navigate in both direction. Okay, now a node in singly linked list cannot be removed unless we have a pointer to this previous node. Of course, when we had the nodes in the singly linked list and when we had to delete a particular node, let's say we have to delete the node at particular position equal to 2, 1, 2, 3. Now since we have to delete this node, we need to update this pointer here so that this points to this. Okay, and this link has to be broken, this link has to be broken, and a new link has to be born. So we need to have one more pointer pointing to the previous of this node. The node that we want to delete, we need to have one pointer pointing to the previous node because we need to update this link. So that is why we need to have two pointers for deleting a particular node at a P position. Okay, but if you say if we have the doubly linked list, okay, let's say we have this doubly linked list pointing in two direction, and let's suppose we have to delete this particular node here. Let's say this particular node at position 2, this one. Okay, now let's say if we traversed here and we have to delete, we need one pointer pointing to this node, and of course we have the address of this particular node here. So we can just let's say if this is at 100, so we have 100 here. So we can just say that update the next of this particular node as this. Okay, I mean the previous of this node should be the next in the previous of this node, that is in 100 node at position 100, we can update the next like this part, so that this link is broken, this link is broken, and now this link points here. Okay, and also since we have the address of both these node, we can do the updates accordingly in these two position, right? So we'll see how we can do this, but this is a simple understanding that if we have both the node address, we can do the manipulation of the links right and there using one pointer, right? But here we need to have the two pointers, one pointer pointing back, and so on and so forth. So this way it was a tedious process, but this way it has made it easier. Okay, so doubly linked list has some advantages over a singly linked list, right? Okay, now so I have already told you that in doubly linked list we can delete node even if we don't have the previous node address, because each node contains the left and right pointers pointing to the just before and just after node. But there is one disadvantage. Okay, so what would be the disadvantage? Of course, in doubly linked list we need to maintain two pointers for each node, two pointers for storing the address for each node. So this is an extra memory that is being allocated to each node, okay, for each node, right? So this is one disadvantage, that we have to always put two pointers for each node pointing back and forth, okay? So this is an extra pointer insertion, you can say, extra pointer insertion, right? So this way it is a tedious task, and deletion will also take more time because of more pointer updation, more pointer updation. So this can be one of the disadvantage of doubly linked list. Okay. Now, let's say we have to create this doubly linked list. So definitely we are going to follow the same approach we have followed for singly linked list. Beside here, we need to maintain the two pointers definitely. So for that purpose, we need to have, we already have seen how we can have the structure a node. So struct node we already have seen, struct DLL node, and it will have int data, of course. Then we have two pointers. One is the previous pointer and one is the next pointer, and both these pointer will be of struct DLL node type because it will be holding the structure of the back and forth DLL nodes. Okay, so this would be the structure, and we'll type def it as struct DLL node as, let's say, D node. Okay, so if and yeah, of course, we need to have a node pointer, D node pointer. Okay, we can take the head as node only. It will definitely be node, but it will be having the address of a DLL node. Let's say it is null. Okay, so maybe we can have that as a node because we don't need two pointers here. Okay, but since it is the holding the value of a D node, like a doubly linked list node address, so definitely D node pointer head equal to null. Okay, then inside the main, we had the function that is int I and int n, and we need to ask the user printf enter the number of nodes. Okay, so the user will be supplying the number of nodes that we need to create for a doubly linked list. So percentage %d and at the address of n. Okay, and we are going to call one function for I equal to 0, I less than n, I plus plus. We need to call a function for creating the node. So let's say it is create node function. Again, we have to create and get, okay, and will come out of the function. So we need to create one function that is void create node as we have created for a singly linked list, right? So this is void create node. We need to have one pointer. Let's say D node pointer P pointer Q. We are going to supply the address of P as head. Okay, so this P will be our new node that we have to create. Let's say it is not equal to head. Let's say Q is equal to head. Q will be the traversal pointer. Okay, so for P, we are going to allocate some memory space. So P equal to D node pointer malloc size of node. Okay, so we are allocating the space of a doubly linked list node to P. Now P will be specifying the address, so we will put the head. Okay, before that we need to check whether we have nodes in the linked list or not. So okay, we are supplying the data first to P, so printf enter data for the first node, or so scanf and percent is D, and at the address of P data we are having the data here. Now we have the data, and of course for P we need to have two pointers. First is the previous, so inside the previous we are putting null. So every time you see we have created a new node, we need to update these two pointers. So this is one overhead. Even if we delete the node, we need to have this pointer updation. So this updation of two pointers will be an overhead for a doubly linked list. Okay, so now if we are seeing that if our head equal to null, that is we don't have any node in the linked list, then of course the head is going to, in the head we are going to assign the value of P, and we are making the P as null so that the P unnecessary doesn't points to any space. So we have the head, and we have allocated that head to null. Okay, and this way we are going to come out of this loop. Else, if else we have more one node or more than one node in the linked list. So for that we need a traversing pointer q to traverse till we are getting the next of the node as null. So else q equal to head, and we are checking while next of q not equal to null. So till that point we are going to move the queue to next of queue, and when we get one node with next of queue is null, there we have to insert our new node. So we are going to update the pointers. Let's say we have these nodes already in the linked list. We have two nodes already in the linked list, and here we got the null. Okay, so here we are going to insert one new node. So what we are going to do, that this queue is pointing here. So in the next of queue we are going to provide the p, of course, that is the address of the new node. And what we are going to do in now this points to the newly created node, that is our p, and in the previous of p we are going to provide the address of q, so that this points to back to this node. So here also see we have to maintain these two links, and already we have the null pointer here. So this is now updated with this address, and next of q is pointing to this address, and previous of p is pointing to q. Then we have to make p equal to null, q equal to null, and that's how we have created a new node in the linked list, right? So, sorry, this, okay, we can do this way also. So this way we can create a new node for the number of n input given by the user. Okay, so let's see how we can insert a new node at the beginning of a linked list, and how we can insert a new node at the end of a linked list. So, sorry, doubly linked list. We are talking about now double linked list. So that's all for this part of video, and thanks for watching. Bye.